All right, we'll go ahead and get started. So yes, we're with Salt River Project. We weren't planning on giving a presentation this year because we figured everyone was getting tired of our simple implementation. We don't have anything cool and sexy and no integrations with WAM and GIS. Well, hey, this guy needs to lose some more hair. Take your hat off, Jason. All right, so just a really brief introduction. What I'm going to be doing is going over the background, kind of how we got to where we're at right now, and then giving a brief AUD overview. One thing I noticed that a little more than half of the crowd is probably familiar with AUD, has an AUD implementation, but I ran into a number of people yesterday that were thinking about joining the club and looking into AUD. And so I wanted to take a quick opportunity to just kind of paint the picture of what AUD does, how it does it, and then we'll turn that over to Jason. Jason will give us a demo on how SRP uses AUD in our day-to-day activities and show some cool stuff that we've implemented. And then finally, Jesse's a designer, and he's actually using the tool on a day-to-day basis. And Jesse's experience is good. I'll let him share most of this, but he's used the designer in basically two facets. One as a drafter, and then one as a designer. So he has a lot of good experience to draw from. So with that, so the background for our group and our implementation, about 7 years ago or so, a small group of designers, we got in a room and we're like, hey, we know there's a better way to do what we're doing. We had all this tribal knowledge that was in everyone's head, and we had like 7 or 8 manuals that our design staff had to know and memorize in order to do their job effectively. And oh, by the way, to make certain design decisions, they had to go into various spreadsheets to run cable pull and voltage drop and you name it, right? And almost every designer had on their cubicle wall had paper taped that said, remember this in these scenarios, remember this in that scenario, and remember this CU when you do this particular operation. So all of that information was just out in the ether that had to be remembered and gathered and used at the appropriate moment. And we understood there's got to be a better way to do this. So we did some research. A small group of us looked at various competing alternatives, and we chose AUD partly because, and largely I would say because, of the ease of configurability. In other words, we needed a tool to do design work, and the design staff, us, were going to create that tool. We did not want to rely on IT to build something for us, and then we get it back 3 months later and we say, oh, no, you totally misunderstood the requirements. You need to change X, Y, and Z. We wanted to be responsible for our own destiny. So we decided, okay, we want AUD. We brought it in. Dan Layton, shout out to Dan, helped us a lot getting our feet off the ground. Within the past year or so, we've had Atwell help us do some configuration, offload some of the stuff from Jason, who's been doing the bulk of the heavy lifting there. And I kind of mentioned it. We did a rogue implementation. So we did not want to be encumbered with IT. All we wanted to do was make our design staff more productive. That's it. Our intentions are, once we make our design staff more productive, all of these related activities, they're going to be coming to us to leverage the information that we're creating on a daily basis. So it'll be a no-brainer for our Maximo team or our GIS team to leverage the information that we're creating on a daily basis for their own purposes. And that is also reciprocal, right? We gain from them, they gain from us. So this is all in-house by a couple of designers that know about that much. So a little bit of background on AUD and kind of what it does and how it does its thing. You pretty much start off with an equipment, what I call an equipment model library. The word model is used a couple different ways in AUD, but equipment model library. In other words, SRP has 12,000 CUs and probably 12,000 more individual stock codes. Each of those CUs represent a specific piece of equipment in the field. We had to build models for each of those pieces of equipment, right? So we have a model, yeah, you can see it on the screen, for an underground single phase 25 kVA 12240 transformer. That represents a physical object in the field. It has CUs associated with it. It has engineering calculations associated with it, and that is repeated throughout our library. Each model has attributes, as I alluded to. So apologize if you can't see it, but the transformer has attribution like the CU, the removal CU, which may be different than the install CU, right? Reactance, resistance. We have a calculator field that allows us to input min and max house size for subdivisions so that we know what the voltage drop and flicker is going to be based upon the load from those min and max house sizes, okay? We can put all that stuff and many more pieces of information into those models. A lot of this is out of the box, but also some of these fields are things that we added. Like, does the customer provide the conduit, yes or no? Is the pad included in the transformer, yes or no? Is a transformer feeding a street light, which is important for us? We have to signify that. So it gives the designer the opportunity to really spell out, hey, what am I trying to accomplish with this design? And then have a model which represents real world facilities to make those spatial decisions inside AUD simultaneously. So we take the equipment library with its associated attributes, and then we have a rules library, right? So the rules basically control the behavior. I have a transformer model, but what does that transformer look like when I'm in the construct status versus the removal status versus the existing status, right? If I have a situation where I'm running primary to a transformer and that transformer is fed radially, what do? Oh, I minus one of the termination elbows because I get two with a single phase transformer. I minus one of the termination elbows and I add in dust caps automatically, right? The designer doesn't have to go to their cheat sheet and say, oh, hey, remember to do this in these situations. Those situations that we can code or logically apply from our standards, we do so. So we take, instead of having them go through, okay, which manual was it in? Okay, which page in which manual? We're trying to take a lot of that burden off of them. So they can just focus on designing, not what the CU is, right? This particular rule is basically a validation on the pad number. So when the designer or location code basically for an underground transformer. Sorry, I'm talking a little fast because I want to get to the demo. So we take the rules library, we take the equipment model library, and we build our model of what it's going to look like in the field, right? So we take the bits and pieces, we put them together. This is the scope of my project. So I have a really fundamental or rudimentary, I should say, in the upper left corner is our model using 2-scale facilities, right? And I did a little, I don't know if it's meaningful or not, I was just nerding out about 30 and 6. So with 30 mouse clicks and 6 enter keys, okay, I was able to put in models for the transformer, the pad, the conduit, the conductor, the service conductor, the SES, and oh, by the way, all of the engineering. And oh, by the way, at SRP anyway, your utility might be different. We show a transformer at least 3 different ways on our construction prints. So in the upper right corner, that is a view of our conduit 1 line. So in our system, when we have a new project, the customer digs the trench, puts the conduit in. So that 1 line is the instructions for them to do the job correctly. So that's in the upper right corner. The lower left corner is our main line. Basically, this is, and it actually looks a lot like how the GIS will look once the GIS is populated. But this is the physical location of where things are in the field. So the crews can drive to the transformer, drive to the location, right? And then the lower right corner is the schematic, the electrical schematic, which our engineers care about. Might be hard to see, but one thing that might be interesting to you is through our rules, we can configure things like the distance. So historically, when our designers put two pieces of equipment 100 feet apart, they would say, oh, I got 100 feet of trench, and I have 100 feet of conduit, and I have 100 feet of wire. Well, that's not the case at all. I have 100 feet of trench, but my conduit length is 100 feet plus the distance to go up to the bottom of the pad. And oh, by the way, our cable length is our conduit length plus we include 5-foot spoil for termination on each end. So in that 100-foot length, you're actually consuming 116 feet or plus or minus of wire. You can configure that however you want. And so we do it slightly different depending on the device that we're connecting to, okay? For those 30 clicks and 6 enter buttons, I also get a material summary report. All of my bill of materials are listed for me automatically. And in our implementation, we have it set up such that I can list them individually or I can summarize them. So I can have 10 line items of 10 individual transformers, or I can say I have one line item with 10 transformers. Just depends on what the designer wants, right? So I get the material summary. If I had work points here, they would be showing work point 1 to 2, work point 1, work point 2, et cetera, et cetera. All that's easily configurable. Oh, by the way, I also get validation messages. So if I do something stupid, then I get an error message like, hey, dummy, you forgot to put the pad numbers in. Or, hey, you just drew conduit that's over 1,320 feet. And that's violating our grounding requirements. So when you go to put wire in there, you're going to be violating. And so, back up. We did that on the conduit, not on the wire. Because we put conduit in the ground with the intention of putting wire in the future. So if they put 1,325 feet of conduit in the ground and some guy goes, okay, I'm going to throw wire in the conduit now, you just violated the standard. So we check that on the conduit. If the designer wants to bypass that, they certainly can. There's some error messages that we would say, you cannot move forward until you fix this. There's a wide range of flexibility there with how you present those errors and what you do about those errors moving forward. So we check on things like missing equipment numbers. We warn the designer, hey, you got this radially fed transformer, which may be appropriate in that situation, but it's just an, oh, by the way, check this out. Cables longer than 1320, cable and conduit mismatch, trench without cable or conduit. I mean, as you're going through the design process, typically what we recommend is we start with the devices and then we add the trenches in. And so if you get to the point where you're at the end of your design and you have a trench with nothing in it, we tell you, hey, maybe you can delete this trench now. You didn't end up needing it. I mentioned engineering analysis. So we get the cable pull automatically. It's all built into the system. As I'm designing, I'm getting validation results, and I'm getting a visual feedback on whether or not it passed our cable pull. So it'll get a nice little green arrow if everything's cool. I touched on this briefly, but scenario handling. So the first line item, underground cables. So I mentioned the 5-foot of spoils on each end. Pad mount transformers, I think I mentioned that. Transformer termination elbows or dust caps are automatically, right? So if I have an existing, so think about my scenario previously. If I have an existing transformer that's existing radial, and I'm coming along and looping that, the designer doesn't have to remember. Automatically, I'm removing a dust cap and adding a termination elbow, just because I simply attached the primary conductor to the transformer. The designer does not have to remember that. It happens for them. Fusing cubicles. So our fusing cubicles come with stock 85 amp fuses. If the designer says, oh, no, in this situation, I need 100 amp or I need 200 amp blades, whatever, they just make that change in one of the attributes. So get rid of the 85 amp and add 100 amp. The stock codes are automatically taken care of. So on the material list, it'll say I'm minusing this standard stock code from this CU, and I'm adding this new stock code. So the crews get exactly what they need, and they're not left like, what do I do with this extra equipment? Street lights, when we order a street light, you're automatically going to get the J-Box CU, you're automatically going to get the mole bar for the connection. Services, I think Jason will probably illustrate this very well in his demo, but one of our requirements is when we run 13 or more services to a commercial panel, we have to rack and encase it. So the designer no longer has to remember, is it more than 13 or is it 13 or more? What's the rule, right? It just happens. It's racked and encased automatically. And then lastly, mole bars or Z bars. The default is a 4 position. As the designer is adding secondaries and services to that J box or mole bar, that mole bar CU is changing automatically behind the scenes. If he adds too many, right? If we don't have a mole bar that can handle 20 positions and he's got 20 positions in, he's going to get an error message warning him that, hey, you got to do something different, right? So I think that was, let's see. Yep. So went kind of fast. The demo kind of speaks for itself. I'm going to put all the pressure on Jason. So, okay.
Everybody hear me okay? Is that good? Oh, yes? All right. I know everybody, the anticipation, right? All right, so we'll talk a lot about this. We set this up a lot like the field, and Jesse will talk more about it later, but everything we do here is just like the field. We talk a lot about, and Scott talked a little bit about this, is we do trench and devices first. So we have 2 different type of trenches. We have primary trenches and secondary trenches. We do use, I call it the O-line tool, but we use the AUD offset tool. I can set a distance of 5 feet. I can specify where it is, and it'll follow the curvature of wherever it's going to go. I put my primary trench in. In this scenario, I'm just going to do everything as construct. So we'll put in a switching cabinet. I'll put a 4 top tab. And when I go to snap to these, you can see that I can actually snap to it. We set it up a lot like for the drafters. All they got to worry about is the snap settings. The auto connect is automatically set up. Let me change something here real quick. I don't know why that is. Yeah, I'm in trouble. I tell the users don't put nearest on. They're going to yell at me. And then I'm going to put in a fusing cubicle. Speak louder. I'm trying. Put in a fusing cubicle. Like I said, this is just snapping. It auto connects. It breaks the trench at that point. So we just worry about trenches at this point because it's just like the field. They put the trench and devices in first. So that's all we worry about right now. They get that situated. I'm going to put in a single phase transformer. We'll snap it right here. And then I'll put another one in over here. In this scenario, I'm doing like a subdivision. I'm going to do some 3-phase, and then I'm doing like an apartment complex, let's say. I'm going to put a 3-phase transformer over here just to kind of draw something over here for you guys. So as you see here too, these are all to scale. So this is everything we have in here. If you can't, our philosophy is if you can't design it, you can't build it. So that's the kind of how we set it up. And then I can draw another trench. I'll connect it to the primary side. Perpendicular. And you can see all these segments are breaking. So trenches break trenches, devices break trenches. So that's all the user really has to worry about. And then we can put in some secondary trench. And they can draw this however they want. I'm just going to kind of, just to worry about the snap settings. That's all they care about. I'm going to do a multimeter over here. And obviously this isn't scenario. So once they get the trench and devices in, and you can go and erase stuff. So for example, I don't need this. I can always erase it. Just polylines. But this is, If you look at what we're doing here, we just have a trench, and then I have devices connected on top of it with the clearance and a device all built in, all to scale with the clearances built in. They can verify everything as they go. So at this point, we let the users know, then at this point, they can add cable to conduit. So just like the field, trench of devices in the field, now the customer's got to go in and put the conduit in, but we're going to give you the cable for free. So then we just worry about circuits. So what circuit do I need to go from a switch to a fusing cubicle? I need to put in a 3-phase primary line. You just select the segment, and then I hit spacebar, enter. So we're adding the cable and conduit to the trench. If I look at this now, you remember it was just a trench. Now I have 3 conduits with 4 3/0s in there automatically, and it's all hierarchied. I'm adding the cable to the conduit. They're all associated. And you can see the cable pull also ran at that point. I can put in a single phase primary, so I can pick this segment. So you're just picking where you want the cable to go to at which point. There's single phase going to there. And then I'm going to come back and I'm going to pick from the fusing cubicle. The trench always goes to the top. So these poly lines are on top of each other, but the trench goes to the top so the user doesn't have to go in and zoom in every time. You just pick the segments. I'm going to that point. It's going to add the cable to conduit. And then in this scenario, it's 3-phase, which I could have done. Let's see. So I need to go from the switch, past the fusing cubicle, to the 3-phase transformer, and I can click on that. And it'll actually bypass it. So it automatically connects, puts the sweeps in at each of those devices. If I was to go look at that cable, you could actually see that it sees the fusing cubicle, but it does not connect to it. So you can see that it sees it, but it won't connect to it because I didn't stop it. It only connects it at either end. What Scott talked about earlier is we have our little cheat sheets for our services and all these different scenarios. And what you have to do, we have these built in. So if you look here, we only have one spot for service cable. I can use that for single phase, 3-phase. I can use that for whatever because it uses the chart. So in this scenario, it's 3-phase. And if you watch the transformer, you can see that this one's actually going to have 13 or more conduits. And so it's automatic. That one didn't work. It didn't connect. So let's run some validations. So you see here, it connected. In this scenario, I have 13 more conduits, so we have to put a J box or a pull box in front of this. For this, you can see that it's automatically included as part of the 2-scale symbol. And you can see that it automatically put in 13 750 cables with 19 conduits. So I didn't have to go look at a chart. I can use that same button to do a multimeter, an apartment complex, let's say. And it does the same thing. So this is different. Obviously, I'm going to get 1/0 here. I'm going to get 2.5-inch conduit. I use the same exact button. It just uses the SES to calculate and looks at our charts and gives it what it actually needs. So this is the model. Once they've done with the model, people ask this all the time, well, how do I see what's going on? Well, there's the expand feature or schematic feature that's built into AUD. So we have expand primary. What the users do is they kind of look at what the schematic's going to look like. So if I want to see what this looks like, I can select the whole thing. It filters out only the primary. I can set how far I want it away. So in this example, I want to say 5 feet, and it pulls all the primary cables out. I'll turn off. We also have a layer toggle in here. So it'll turn off the background to let the user see what's kind of going on. There's expand edit in here where I can move these around. So for example, I can say, well, I want this down here. Say I want this over here, and I got 2 primary lines here, and I can visually look at that, and it's all built on top of each other. It's still associated, so users will use it to actually select it in there if there's a big list. I can do the same thing with the conduits. So like I said, the primary lines are just built on each other. I can select it, say I want my primary lines down here by 10 feet. I can move them. They're a little bit thinner, but I can still use the expand edit. So I can move it around and manipulate it however I want it to look like for the conduit, let's say. Say I want this down here. They're 5-foot increments. You can configure that any way you want. If I leave it expanded, I'll turn the layer toggle back on. So you can kind of see what it kind of looks like. It's a little bit easier to see when it's off. But at that point, we do our 1 lines. So as Scott showed earlier, we represent a transformer 3 different ways, and we have 3 different layouts. So we leverage the 1-line tools. So if I just draw a box around this and I hit 1 line, after I've done my model, it literally will create my mainline schematic and conduit for me automatically, and it drives the rules. And then it's all annotative. So everything in my model is 1-to-1. So I can have a 40 scale mainline. I could have a 60 scale schematic. I could do whatever I want because it's all annotative. So I could change it to say 40 scale and you would see how all that's set up. And at this point, it's just basic drafting. I'm just moving. I don't have to pick the symbol. I don't have to pick the layer. I don't have to pick anything. All the line types are set for me automatically. Everything's masked. It's just moving stuff around. The cool part about one lines is I can manipulate these any which way I want. It does not affect my engineering. It doesn't affect my materials. It doesn't affect anything. I could literally stretch this and move this all the way over here if I wanted to. And it doesn't affect anything. I can make that look however I want for the customer print. But my 2 scale is always exact. And as you see here too, we talked about the racked, where's it down here? The racked in encasement Scott talked about. We have some information where we can say we don't want to show annotation. We do want to show annotation, so I can associate the annotation. It all comes in. If I change it on the model right now, all that would update. So they're still tied back to the model. For example, if I come over here to the schematic, you can see the offsets are still set. Remember when I had it expanded? It kept those offsets, so I don't have to go move 6 lines. They're already done. Now, if I collapse it, it's still done. It's just a copy, but they're tied back together. I could be in the conduit and realize this shouldn't have been an A-phase transformer. This should be a B-phase transformer. I can literally just change the transformer phase, and it will literally update everything. My annotation, the color, in every single layout, not just the one. So that's the beauty of it. And you can manipulate it any which way you want. We do have dynamic blocks built in with AUD. For example, if I select this in the feature info, these are dynamic blocks, but I can adjust them. So if I wanted that top tap or the molten to be on the other side, I can flip it here and it'll flip to the other side. If I wanted the tap orientation to be the right, I could flip it there. You can drive all that with your dynamic blocks. But at this point, it's just manipulating, make it look however I want for my prints. It doesn't affect anything I've done already to scale, and it's precise engineering quality. Am I going to bypass the other stuff? Is that good for now? Yeah. There was some other stuff, but for time constraints, I won't show you guys. If you guys want to see some of the other stuff, you can, but
Leave them wanting more.
yeah, leave them wanting more. So yeah, you can manipulate these. Like I said, we even have the jumpers in here. So at this point, it's just polylines. So it's just basic drafting. I can literally draw a line to this point, and then it's just a fillet command. And I can say I want this to go to here, and it's joined together. You can manipulate the jumpers. So in this one, it's the conduit. If I wanted 4-inch instead of 3, I could do that. If I wanted it to be bottom or top right, I can flip that. There's a lot of stuff you can do for the users just for prints. This is for printing purposes. It doesn't do anything else. But if I adjust something here, it will adjust somewhere else. So if I look, I'm just going to look real quick. So this is 200, where is this? 236 feet. If I actually take, and because they're all tied together in the hierarchy and they're connected, I could actually just grab the clearance and say move this over 5 feet in my model. And everything just updated. So now it won't be 236, it'll be 241. My wire just updated, and so forth. The pad details are the same way. I could adjust those pad details here, or pad numbers, I should say. I can just put in a number, say on my schematic, but now it just updated on every single layout, including my model. So you can do it in one spot and it updates everywhere. So really cool features. So I think with that, I'll turn it over to Jesse real quick.
So we were timing that whole design was 6 minutes to get the material, all the calculations, the design, and all the layouts on that.
Yeah, we didn't get to some of the stuff, but if you guys want to see it, I can show you. I have some stationing and dimensioning stuff, staking. It's not built into AUD yet, I hope. Maybe we can get that in there.
Jesse can do the design in 3.
Yeah, I do it in 6, he does it in 2.
Sure, something like that. I'm pretty loud, so I'm going to say, could you see me instead of could you hear me? Because I'm pretty short. I know, I got you. I feel you. Anyway, so as everything, when you're trying to train something, you bring something new, you have about 10% of people that like it, want it, are curious, and they'll test it out. So I was part of those 10%. We tried all this stuff. Trying to convince 90% of people to jump into this, you'll drive them nuts, especially when they have all these stuff on the walls, right? So there is a big learning curve. And trying to convince people to go through that learning curve is kind of challenging. And then you have the two differences. We have the drafters and we have the designers. Trying to split this up into two and trying to explain it, it becomes mind-boggling dealing with just so many different people. So something that we've kind of come up with that works is if you grab everybody, you put them in the class for a week or 2 weeks, they'll go back to the office and they don't remember jack. They just remember that there was some guys in front talking too much, and that's all they remember. So what we decided to do, something completely different, is we went from talking about the program to making it more of a people business. We then switched it as, we're going to be in the people business. We're going to go to individuals, and we're going to connect them to the field. All this does, all AUD does, is it's an assistant to help the individual out in the field build it. So what we started doing is we came up with a training system to connect and have the field collaborate with the office. So we basically never even mentioned AUD. And the only thing we told them is we're going to use AUD so that you understand what they do in the field. As Jason did right now, first he did the trench, then he added conduit, then he added the wire. So what we started doing is building a story. Hey, we want you to understand what they do in the field. So we want you to do a trench. Then we would make them do a trench in AUD so they can visualize it. Then we need you to connect that equipment to that equipment. How do you do it? You add conduit. So we started building a story in training. And then these individuals that had those things on the wall that do not trust AUD, the big analogy or example I like to give is get a farmer who's used his horse all the time. Bring him a tractor. And then tell him, hey, this is going to help you build that a lot faster. And by the way, that little pedal will make it go and stop. You probably won't convince him to get in that if he's never seen a tractor. This is basically what we have. We're taking somebody from a certain technology platform to a thing that they will not trust. Hey, this does the calculations to you. Bullshit, I do them better. It's no matter what you tell them, that's what they come up with. So we decided not to even mention it. It's more of, we're going to help you understand what the field does. And in there, you will have questions. Let's go through them. And we'll have people, the pooling calculations are wrong. You're probably right. Let's get engineering involved in here. Let's talk with them. So we started connecting our drafters, our engineers, to people they usually never talk to. So AUD has actually become a tool for training existing and new people, and old habits have been going away little by little. Because this is now forcing people to follow standards. It seems like you are all in the same boat that everybody does whatever the hell they want. And trying to convince somebody to use standards is extremely hard. AUD has become the tool that we're, quote unquote, forcing people to go that direction. So it's become a training tool, getting everybody aligned, and we're using it as an excuse versus telling people how good this is and how fast they're going to be after they use it. So our training strategy is quite a bit different. Since we're short on time, hopefully that made sense.
So is this just implemented for your underground SCS or all distribution? And what about your overhead crews?
So we are in the customer construction group. So any jobs that come through that are customer driven are using this tool, including overhead. We are technically an overhead company, but most of the stuff we build is underground. There are some really cool tools for automating the overhead construction. Point A, point B could be 1,000 feet apart, and it'll put poles based upon your configuration. The right pole height, et cetera, et cetera, et cetera. So does that answer your question? Okay, thank you. Front.
Go this way.
Get some cardio in, Pat.
On the section where you were showing us the one-line drawings, is it possible if you took like a customer survey where you could overlay the one line onto the survey for like a developer?
Yeah, absolutely. Yeah, a lot of our projects start with a customer supplied CAD file. And in fact, we can do one better than that. We can take their existing blocks and turn them into our features. So we have some developers that will locate the switch cabinet or the existing transformer or whatever, and or streetlights, and we just click on those and say replace, and we turn it in from a dumb block into a smart AUD feature.
That is the customer product.
Okay, so you could get,
Convert it to our layer.
so you could get basically the one line, or is that what would
Yeah,
print out,
it
or
would
like
be-
what would the customer see?
It would look more like this. On our main line, it would go on here like this. Probably more like this, straight. It would look more
Okay.
like that for the customers. Schematic
Oh,
and
great.
conduit, we don't do that for, but
Okay,
Yeah.
cool, thank you.
All right.
Can I see the stationing feature?
we have to station the center line first, or the alignment, so I can just pick it. This is also layer driven, so if they don't have it on the right layer, it actually will kick it back at them. We're not gonna give it an alignment name. It asks me which point do I want to start at, so I can specify that. And then it says what format do you want it in, so say 1 plus 0, 0. And then it asks me which direction do I want to increment it from, and then I just pick the line, and it'll go ahead and place it. If it's a polyline, it'll follow that curve which way it's going to go, and it'll stop. I can do the same thing. Say I'll just do it here too again. No alignment name. I'll pick the point. Say this is 10 plus 0, 0. I pick the direction. And I got an error, but you can go through and do that. And then after that, after you've had the center line stationed, we have station equipment. So I can station a pad. So if I just pick the center line, then if I go pick the block, so say I pick this transformer, it tells you down on the command line, if you're standing on the center line, pick the left side of the transformer, pick the right side of the transformer. It makes it a little easier. I can pick the left side, I pick the right side, and it'll give me the points in the left or right. So it knows if it's incremented. If it's on the right, it would have been the right. If it would have been the other way. I can do it by a point if I wanted to. So if I had just a device point, so if I had a street light, I'm just going to pick a transformer. It'll just give me the insertion. It'll actually give it to me automatically. We also have, if it was a trench, I can do like a point, like if I had a 45-degree bend for a trench and I got to station that. At this point, I can pick any part of that trench and it'll give me that station and offset exactly. So you saw I drew my trench at 5 foot. It was 5 foot off the right of way, so it knows it's 30 feet off the center line total. And then we have some features in here that I can copy this down to the main line. So will copy it down from my print. So it'll just copy my station information and my points for me automatically. So I don't have to redo it. It's kind of like the one line tool where it literally creates it and you can patch those in as needed. So there's a patch feature we didn't tell you guys about either, but it's the same idea it works similar to this. If you put something in and I need to add it to my one lines, I don't want to run my one lines because I've messed with them. There's a patch feature where whatever you select, it pops up a dialog that says which layout do you want. If you do pick the wrong one, it will still run the rules. I can still pick it and it'll put that device in all my layouts. So you can patch things in as needed, but stationing works the same way. Does that answer your question? All right. We do it real quick. Since Pat's giving me some time, I'll show you the other one. This we haven't implemented yet, but we just got it done. SRP dimension, because the users are setting up the base map correctly and put it on the right layers, instead of having to do all the dimensions all the time, they can actually just pick the center line and I could draw a box around this and it'll put all the dimensions in for me and label them for me automatically. So they're doing that manually one by one and have to edit it when they can just pick the line, and as long as the layers are correct, it automatically gives me the dimensions. So if it's front of curb, back of curb, sewer, water, it increments it all. And it's just basic AutoCAD dimensions, so you can manipulate them. I can move them wherever I want. They're all masked everything already, so. Any other questions?
Yeah, our focus was to make the designer's life easier. We'll worry about integrations later. Pat, any other questions? No questions on Rogue implementation. Okay, good. All right. Oh, in the back. Who's that guy?
Say that again, I can't.
I can't hear you.
Is it on? Did you complete those tasks with Lisp as part of your automation?
The stationing and dimensioning? Yes.
Thank you.
Right behind you.
Is that bad?
Is Lisp a 4-letter word?
It's until they can put it in the AUD, then we'll use it. But
Yeah, go ahead.
So it's a rogue implementation. How long you started? So give me some timelines.
Yeah,
And
absolutely.
did people have to do work? So were they fractionally available, full time? How'd that go?
Yeah, great question. Great question. So it was about 7 years ago. A group of us got in a room. We're like, hey, there's got to be a better way. We came up with a list of like 10 things that we needed, and we put a little like RFP together for our IT group. And we said, hey, we think there's tools out in the industry that can fulfill these needs. Get back with us. Let us know what some options are. We can check them out. IT said, we really don't have time for that right now. We're involved in these other things. So our director goes, you know what? Go find out on your own. So fractional availability, he dedicated some time for us to go and do some investigation. We went to a number of different utilities. NV Energy actually was one of the utilities we investigated. And we decided on AUD. So at that point, my immediate manager gave us 50 grand. And he said, I want you to put a pilot together. So for 50 grand, we put a pilot together, doing a handful of things, not too dissimilar from what you saw, right? And we presented that to senior management, and they're like, wow, this makes a lot of sense. This checks a lot of boxes for us. And they said, well, what do you need for full implementation? And so through very sophisticated analytical abilities and thorough research and dedication, I pulled a number out of my brain, and I said, for 2 years, in 2 years and 500,000, I can get this done. And they're like, okay, do it. I'm like, okay, now it's time to deliver. So we got Jason at that point dedicated pretty much full time, and I think there was another employee that was part time, Chuck. And we engaged a lot with Dan, and we built we started down the road. So our approach for implementation, again, was focusing on what does a designer need. So we didn't look at all 12,000 CUs and said, okay, we need to build these 12,000 CUs and build this model library first and foremost. No, what we did was we put all of our designs on a wall, okay? And we said, here's an example of this type of design and that type of design and that type of design. What's the commonality, right? What do we do things, how are these things similar? And let's focus on that first. So every design uses a trench. Every design has a switch somewhere in it. Every design has a fusing cubicle. And we just kind of went down the list. As we went down the list, we found pretty quickly that those things that we have implemented, we could deliver to our design staff immediately. So in that 2-year process, we were already putting jobs through production. It wasn't like we were in a room for 2 years and then we got back to management and said, okay, we're done, here you go. No. We were rolling stuff out as soon as we thought we had enough for our staff to use. And that was good for us because, one, we can get some comments and feedback on how we've done, and they help build that tool, and we just go down the road and we continue building value. Are we completely done? No. Will we ever be done? Probably not. Probably not. There'll always be something to work on, especially in overhead. Actually, it was funny. I'll back up. One funny story. So we put all these designs on the wall, and I've been in design for 30 plus years, and I'm like, yeah, we never do manholes at our group. Normally manholes are done by our distribution improvements or a system group. I'm like, our jobs, we never do manholes. So we roll out what we've completed to this subdivision guy. And he goes, hey, my job's putting in 3 manholes. We're like, oh crap, what do we do? So Jason had to develop and fill out, with the help of Dan, the manhole library, which, took a little bit of work, but it wasn't more than a week or so, I guess, right? I mean, so that was just one of those things, like, you got to be responsive to your customers. So what did I not cover? And so at the end of 2 years, like I said, we've been in production. We're pretty much doing every job type that comes out of CCS. So Did I answer your question sufficiently? Okay, good. No, system improvement, they decided that they wanted to listen to what IT had to say. And IT is in bed with that other company that I won't name, which was one of the big challenges that SRP had. We're a historic legacy microstation user. So when we started this project, IT said, you'll never get AutoCAD at SRP. And we're like, oh, really? We'll see. We'll see. And you'll never be able to do what you're planning on doing without us. And so we did it. And our sister department is gone to them and say, hey, we need help. We want something like what those guys are doing. And the default response from IT is, well, we got this other tool over here, which they can't get off the ground. And individual users in that group want what we have, but aren't allowed to get it just because of politics. Yeah. In fact, Power Engineering does some of our consultant work. One of the good things about AUD is you can just share your template. And Atwell does some design work, so we just share our template with these construction or consultant companies, and they're immediately able to understand and use our standards in our job. They don't have the onboarding time is reduced quite a bit. Has the sister department considered switching? I think to a person, they're realizing that IT can't deliver what they're promising. To IT's credit, they got a lot of things going on. You know, they're in the middle of an ADMS project on the GIS. They're upgrading the GIS, this, that, and the other, right? So design is like way down here on the list of things to be worried about. They're not going to be able to deliver. And I think at this point, I think our senior manager, who is the senior director who's over both of these groups, is kind of just letting them hang themselves, giving them enough rope. We've said, hey, we've invited them to come on board. There's a dime's worth of difference between what they do and what we do. The only difference is the input. Who is the customer? Is it a municipality, or is it a developer? I mean, the CUs are the same, the crews are the same, everything's the same. So we can handle that if and when they decide to get on board. Anything else? Are we the last ones between you guys and lunch?
Lunch isn't here yet. So
Oh.
You want to go, Brian? You ready?
Oh, up here. You know, I'd have to go back and look at my notes. Autodesk had a spreadsheet, and in that spreadsheet, as I recall, was like, okay, how many features do you have? And then you could plug stuff into a spreadsheet and get kind of a rough number. I probably added some fluff in there to just protect myself, but I would love to say it was something really sophisticated, but you know, I guess I leaned a little bit on my experience having been working for the company. Oh, we came like probably 5% over. Yeah, I mean, it was, for our purposes, it was right on. Yeah. And that included licensing too. Buying all the licenses that are required for AUD to run.